Good morning, everyone, and thank you for joining us for the next instalment in our webinar series. In this webinar, we'll be discussing value engineered solutions and how MGF have previously overcome issues both efficiently and with complete knowledge of the excavation. Looking at 3 case studies in particular that we have been involved in early on in the project, we are going to focus on the key benefits of this to both the customer and MGF, and how we reactively overcame any issues encountered. MGF are recognised as one of the leaders in the design, manufacture and provision of modular and bespoke excavation and structural support solutions. We are committed to providing our customers with complete engineered solutions and promoting current best practice for all types of excavation and structural works, with supporting safety, piling and lifting departments. I'll now invite today's team to introduce themselves.
Thank you, Gemma. My name is Lisa Burry and I'm Technical Sales Rep for MGF covering the SW1 region. That includes South Wales, Gloucester, Cheltenham and Swindon.
Hi, I'm Richard Ray, Senior Engineer working from our main design office in Astley near Manchester.
Thanks both. As usual, there is a chat box and a Q&A box at the bottom of Zoom. Alternatively, you can send your questions through as an email to marketing@mgf.co.uk, and we will go through all of these at the end of the presentation. So let's get started. I'll now hand over to Lisa, and I hope that everyone enjoys.
Thank you, Gemma. Good morning, everyone, and thank you for joining us for this morning's webinar. I'll briefly run you through the agenda and then I'll pass you over to Richard to carry on from there. So we're going to cover the benefits of collaborative working with our customers and the key elements of and benefits of being involved early doors. And then we'll run on to some case studies then. The first one being with Blue Dot Construction, then one with Knights Brown, and lastly with Lewis Civil Engineering. We'll have a summarise at the end, and then we'll go on to a Q&A session. So Richard, I'll hand over to you.
Okay, thanks Lisa. So let's just look at the benefits of collaborative working and its aims. So the main aim of collaborative working is to ensure that we achieve an optimal design solution for the customer, not just in terms of minimal cost, but also looking at the wider issues of the programme delivery, and also increasingly important these days, sustainability. So working collaboratively gives us time to gain a full understanding of the job and the customer's requirements, and this feeds into being able to produce a valued engineered solution. It's important that we are able to gain an appreciation and awareness of all the requirements of all the customers' requirements and restraints as an earlier stage as possible, to ensure that the design process is optimized and that any delays on site during the execution stage are minimized. So yeah, just in terms of getting involved earlier with the customer, obviously the earlier the better. The earlier we can start looking at the scheme, especially with the larger schemes, the earlier we can start offering input and working with the customer to achieve their aims, and ensure the solution is the best option for them in that situation. It's always better to iron out all the issues and be in the design phase rather than trying to catch up and mitigate problems when they go wrong on site. It's always going to be more expensive to do it that way around. So the earlier we can get involved at the early stage of the scheme, the better, rather than having things go wrong or things not being picked up or appreciated at the delivery stage, when it's very difficult to rectify and can add significant cost and delay to the programme. Now Lisa's just going to have a look at a couple of case studies where we've actually being able to get involved early and offer significant benefit to the customer.
Thank you, Richard. Okay, the first case study we're going to look at, well, both of the case studies I'm going to look at, I was heavily involved in. The first one being with Blue Dot, which was based at Mega Euro Parks in Newport. Phase one on this scheme was to install 3 attenuation tanks. You can see the dimensions up on the screen there. So if I quickly run through the timeline, we started initiating conversations with the customer back in November of last year. Site visit was arranged quite quickly, where I collated all the relevant information, be it drawings, ground conditions, had a good look around the site where they were due to be excavating, making sure there was no hazards or load-ins or anything that we needed to take into consideration when putting the design brief together. The design brief was then put into our design team to start the process, and we came up with an initial concept design for them quite quickly. Looked at a few different options for them, and before Christmas the full scheme was given to them and approved. Break over Christmas, came back into January, and the customer had their design approved by their client and was happy to move forward, so we issued the full construction copy. We commenced on the 18th of January, 2021, deliveries commenced. There were 14 loads of kit delivered in total. We commenced on the 25th up until the end of the job, sort of mid-February. There was ongoing communication between myself, the customer, our operations team, and regular site visits just to make sure everything was running smoothly. Towards the end of February, the job was completed and the kit was collected. So to look at this case study in a bit more detail, there was initial review of the design, which highlighted very poor ground conditions. We knew that there was going to be potential of a high water table, and the ground was potentially going to be a mixture of peat and running sands. We went back to the customer for a feasibility review where we went through the concept design and made sure that they were happy to handle the kit that we had suggested, i.e. the length of the sheets or the weight of the tank brace. Regular communication with the customer continued, and we suggested a ground reduction might need to be taken into consideration, as it might make an easier install of the sheet piles. Alternatively, an extra frame could be added. The customer decided on the best option for themselves. The design then went through to full scheme and was submitted to the customer. The customer informed MGF that all kit for all 3 pits would be required at the same time. Now, we had just over a week, 6 days, I think, in total, to collate all the kit from various depots and coordinate all 14 deliveries. The customer was happy to report that they'd had a successful install on site of the 3 excavations. The job was completed, kit was off-hired and collected efficiently. And we are happy to report that there were 0 damages. On this next slide, you can see a few examples there of pictures of the 3 tank installs that went in at different stages. In the middle there, obviously, that would be where the tank has obviously been installed and the kit is gradually being taken out of the ground and then backfilled. The one at the bottom there is where they've taken the bottom frame out, put the concrete base in and then taken the bottom frame out. We've also got there the design or part of the design that we gave them. You're obviously looking at your plan view there. As you can see, there was cross struts. We're not looking at the full design there. We would also supply them with a 3D Revit drawing and installation sequence, which we'll see probably on the next case study. So moving on to the last slide for this case study, there was fantastic feedback from the customer, where he was over the moon with how the installation went, everything from the design to the delivery, the removal from site. It all just went absolutely to plan, but more so for them because of the ground conditions they encountered. It was a very straightforward install with no issues encountered. And we hope to work with Blue Dot again on the next phase on that scheme. So moving on to our next case study. This was another scheme that I was heavily involved in with Knights Brown down at APP Docks in Newport. Basically, they were installing 2 tanks, again, attenuation tanks, but on this occasion, they were going to do them one after the other. So they were going to use the same set of kit for both tanks as they were exactly the same dimensions. So quickly running through the timeline, again, we were speaking to them a good couple of months before any kit ever arrived on site, giving us a chance to run through various options, collate all the information and so forth. So in March of this year, the initial inquiry came through. I arranged a site visit, collated all the information again, drawings, SI, walk around the site to make sure there was no loadings or hazards that we needed to be made aware of. Design brief was then put into the system. Between March and April, there were a few revisions that went back and forth, looking at different options for the customer, which is where the early intervention is very important, because it gives us that chance to come back with the best solution for that customer. And then later on into April, then the construction issue was given to the customer and we were ready to go when they were. So on the 24th of May, the deliveries commenced of the kit. But unfortunately, upon installation of the first excavation, on the 2nd of June, I received a phone call from Knights Brown to let me know that they'd encountered an issue on site. So I arranged an urgent site visit for that afternoon. We quickly redesigned same day, and extra kit was delivered to site the next morning. End of June then of this year, the job was completed and the kit was off-hired. So to look at that case study in a bit more detail, the cofferdam was actually made up of 6-metre GU13 sheet piles and 2 frames of 406, 305 and 203 combination tank brace. The coordination and delivery of kit was very successful. Owen at Knights Brown was very specific on in what order he wanted things delivered, and we worked with him to make sure that ran smoothly. As I said, on the 2nd of June, I had an urgent call to site as excessive deflection was encountered, approximately double the amount that was expected by our design. But we believe that this was down to a pocket of soft ground just outside of the excavation. As stated earlier, I visited site the same day. We promptly redesigned and extra struts were delivered to site the next morning. No further issues were encountered, and the kit was taken out of tank 1 once the tank was installed and backfilled and reinstalled into tank 2. When tank 2 was excavated and the kit installed, no further issues were encountered. And we're happy to say the job was completed, the 2 tanks were installed, the kit was off-hired, and we had minimal damages encountered. So here we can see some pictures of the first excavation, where you can actually see how much those sheets on that top frame was deflecting. Going on then down to the next excavation that was completed, where they encountered no issues. That's pretty much to the letter there, and a nice aerial view of the bottom picture there. To your right there, you can see the design drawing that was given to the customer. So you've got your plan views of one of the tank excavations, the 3D Revit view, and the installation sequence at the bottom. So I'm happy to say that the customer again was over the moon with how things had gone. Yes, issues were encountered on site, but this, was unforeseen by anybody. The customer couldn't have predicted what was going to happen. What they were happy with was how we responded so promptly, and basically rectified the situation, so there were minimal delays to their construction schedule. And I'm also happy to say that we've worked with Knights Brown on various projects since. Okay, I'll hand over to Richard now to continue with his case study.
Okay, thanks, Lisa. So this is a job I did for Lewis Civil Engineering. I think it was completed last year. There's a couple of pictures there you can see of the finished result. So we're just going to go through now and just have a look at a bit of the process as to how we got there. So it's a reasonable size cofferdam for a new pumping station, about 21 metres long by 13 metres wide and 6 metres deep in Coedil, that's in South Wales. So the design did actually go through quite a number of revisions as part of the development process, but importantly, the customer had come to us with plenty of time to be able to do this without it all becoming a mad panic as they needed to hit delivery timescales and deadlines. You can see there that they initially came to us back in 2019 for an initial concept, and it wasn't until October last year when the scheme was actually completed. So we'll just have a look now at a few of the issues that caused the number of revisions. So every scheme, the customer will have an initial input and ideas, and that's often based upon the particular site management team they have. In this case, there were a couple of changes to that management team, and naturally, different site managers have different ideas. So about how they want to go about the scheme and install the equipment and how much working room they need and that sort of thing. So that inevitably required a couple of changes to be made. Next one is the cost, which is always a key driver. It's always probably the first question that the customer asks. However, it's not just about pure cost. We also have to consider the value of the scheme and how we can improve it for them to ensure that it's the optimal solution in terms of not just the cost, but the buildability, the risk, and the program. Revisions to permanent works, that's always an issue particularly on the larger schemes, because permanent works and temporary works don't just stand in isolation. They're obviously linked. So any changes to the permanent works design can potentially require revisions to the temporary works design, which is what happened in this case. I think there were some changes to levels and plan dimensions, which had obviously a knock-on effect to our solution. Ground and groundwater conditions. The nature of any sort of ground engineering is that it doesn't matter how good your SI or comprehensive your SI is, it's not until you actually get into the ground and start digging that you see what you're up against. Fortunately, in this case, the ground wasn't actually as bad as the SI had suggested, and the groundwater was a bit lower. So we managed to actually take some of the reduce some of the frame sizes and reduce the amount of towing required on the sheets to the benefit of the customer. They didn't need such a big plant to install the sheets, and also there was a bit of a cost reduction on the hire of the equipment. One other factor that can sometimes affect designs is equipment availability, and that's more of an internal factor, but it's just the nature of the equipment hire is that despite having a large fleet of kit spread across all our depots, you never expect to have every single piece of equipment available every single day of the year in every depot. So sometimes you have to tweak the design a bit to suit the availability of the equipment you have. But due to the modular nature of the equipment, this is quite easily done and very rarely results in any delays at a site level. Right, so we'll just have a look now at how we set out with an initial concept and then move through the process to the final design there, which you can see on the right. Initially, the scheme was developed to give the customer a completely clear, open span, which would have been great for them in terms of being able to excavate and install the permanent works. However, due to the large span of the excavation and the depth, this would have required using one of our heavy tank brace, which is called a T700. Due to the weight of the sections making up that frame, it wasn't going to be practical for the customer to get them onto the space constricted site and lifted into place. So we had to look at how we could still form the opening they required, but with lighter kit. As you can see there on the right hand side, we did this by using knee braces in a lighter frame, but still gave them enough working room to be able to actually build the permanent works, which was an RC tank. You can see just on the underlay. I won't go through obviously every single revision between the initial concept and the final design, but it was generally like iterations rather than any massive changes. Just going back to like on the previous slide, I mentioned the number of different factors involved. So each one of those had an impact on each revision, or required a revision to be made. But given the time we had, it was done like in a logical way, and not just like a mad panic at the end. So I'm just going to pass over to Lisa now to have a wrap up.
Thank you, Richard. Okay, to summarize then, we've seen some really good examples here of how we've worked with a collaborative approach with our customers. We've been involved early doors and the benefits of that. I think what we've seen is the earlier we are involved in schemes only has benefits to both MGF and most definitely our customers, as we're able to have the time to offer valued engineering and the time to evaluate options and deliver the best option for our customer. Thank you very much.
Thanks, Lisa and Richard. So before we take some questions, I'd just like to let you know that there will be a feedback form that pops up in your browser at the end of the stream. So please fill that in with as much detail as possible. That would be a great help for us to continue to improve our webinar series. If there is any theme or topic that you would like to see in future webinars, please let us know. The next instalment in our webinar series will focus on the recent launch of MGF's new lifting division and takes place on Wednesday, the 3rd of November at 11 o'clock. We hope that you will join us for any future webinars, and you can find out more details on our website. So we'll now look at some questions. So one question that we have had through from a customer that came through during the case studies is, what involvement was there with the principal designer and or the temporary works coordinator?
Which scheme? Do you know what scheme that was?
Just in the case studies given, so the case studies that you've gone through, but that did come through during the Blue Dot case study. So maybe Lisa, you might want to answer that one.
Yeah, I think for me, I was mostly every scheme is different. On that particular one, I was mostly dealing with the site manager, who was then liaising with his temporary works coordinator and their client and principal designer in the background. Then he would come back to me then with either questions or, you know, edits that needed to be done to the designs, or to sort of basically say, yeah, client's happy, temporary works are happy, can we have a full scheme? But it does change. It depends on each scheme. Sometimes there's more involvement from the temporary works coordinators from the clients.
Yeah, and sometimes you'll get, due to the nature of the interface with the permanent works, there'll be a significant requirement to be liaising with a permanent works designer, because it's important that you don't have like clashes of equipment with the permanent works, and obviously the permanent works needs to be buildable, so there'll obviously be a requirement to liaise with them depending on the nature of the scheme.
Okay, and just to elaborate on that, was there any consideration for the need or methodology for the temporary works prepared by the permanent works designer?
I don't think there was on those schemes, and quite often we find that the permanent works designers don't always consider the temporary works to a significant degree, where perhaps there should be a bit more involvement from the permanent works designers. It's often just handed over and left to the customer to deal with. So it's something where there is definitely scope for more collaboration as well with the permanent works designer. Because we're really just focused here really on collaboration with the customer, but yeah, definitely there's always scope for better collaboration all round, I think, with permanent works designers. And I think they sometimes lack an appreciation of the impact of change of the permanent works on the temporary works.
Okay, and what design risk were the temporary works, and how were these checked or reviewed by the client?
I think on the blue dot one specifically, if that's what we're talking about, the biggest risk really, because it was mostly virgin ground, there was plenty of space, there were no particular hazards to take into consideration. Obviously, there was the loadings of any machinery or haul roads or whatever that was going to be tracking close by to the excavations. But the biggest risk factor was the ground conditions. As I mentioned through the case study, they were conscious that they were going to encounter possibly high water tables, and the soil was going to be a mixture of peat and running sands and God knows whatever else. But it did turn out that the soft soil conditions were not too soft that they encountered what Knights Brown encountered on their site, but it was soft enough to make the install an easy install for them. The ground conditions weren't quite as bad as we'd taken into consideration. So it worked out for the best in the end, but that was it. There weren't any other risk elements really that was needed to take into consideration.
Yeah, we did have quite a significant tow-in requirement on the sheets on that job, just to mitigate the groundwater and the very soft clay to avoid base heave. But yeah, don't think there were any other issues with it.
Okay, and also just to elaborate on that, you mentioned about the poor ground conditions. Someone's asked, were you provided with adequate pre-construction information such as the ground investigation reports, groundwater monitoring data, or did you have to chase the information from the client?
I think for me, obviously, it's my job to coordinate all of that information and collect as much as I can for Richard and our team of designers. And on I'd like to say that on the 3 schemes that we've mentioned today, we had no issues. I think Blue Dot, Knights Brown and Lewis's all had all the information they at hand. But what I tend to find is you generally get more information on these bigger schemes. It's usually the smaller schemes where we still need that information that we sometimes struggle to get it. So my only feedback to any of our customers or potential customers that are listening is, the more information you can give us up front makes our job a lot easier to be able to work in conjunction with you.
Yeah, it is important that we do get all the information that's out there, because sometimes we'll find that SI has been done, but it's not always made readily available. So in order to produce the most efficient and cost-effective design, we need to get that information.
Okay, thanks. So Lisa, the second case study that you went through, could you please explain in detail how was the deflection occurred? What was the root cause of it? What is the deflection calculated during the design phase? And did you redesign everything when it required an extra strut?
Yeah, well, it definitely went back in for revision then, so everything would have been taken into consideration. But with regards to the technical details, I'm going to pass you over to Richard because he's the best one to answer this question.
Yeah, so in that situation there, I think there was probably a pocket of softer ground than we'd expected, in just the wrong place next to the excavation, and there'd been a haul road next to there was a haul road next to the excavation for probably when it was at the worst possible stage, when it was at its maximum depth. Probably crept a bit too close to the excavation, so the deflections built up over time, and probably they got to about double what we'd have expected in terms of design. We do recommend that the plant loading is kept at least a metre away from the excavation, that might have just crept a bit closer in this case. And also, unlike an excavator that's just like moving around the excavation occasionally, or just in one pass, this was like a whole road, like, so you've got the plant sort of pounding up and down, which is a lot more onerous than like a single piece of tracked equipment, say. But it was important. The important thing there was that the customer actually recognised that the deflection had exceeded the expected design deflection, and got us involved early before it got any worse, or like the structural capacity of the frame was at risk. And we managed to obviously install the struts to mitigate that and stop it getting any worse. So it's just important to emphasise that it is a two-way process. Like, what the customer has to identify when the design isn't working as it perhaps envisaged, and to get in touch with us as soon as they realise the things aren't maybe going to plan, because the sooner they contact us, the better.
Okay, thank you. And another question that we've had through, should the temporary works coordinator provide the full design brief rather than the site manager?
Ideally, it should be a temporary works coordinator. On the larger schemes, we tend to find that the brief has more involvement from them, but on the smaller schemes, there isn't always dedicated temporary works coordinator, or it's often combined with the site manager's role. So we do get a wide variation in the quality of the briefs we receive, but we also have obviously the team of technical sales reps that can assist with the production of the briefs, and can attend site and go through the collection of the information that we need, for example, the SI, and checking out any additional loadings and things that need to be considered like that. Okay,
thank you. So one final question. So in accordance with BS 5975, would these be classed as class 2 or class 3 based on the depth and geographical complexity?
Like anything we've seen there is probably just a category 2. Because they're not massively high risk. It's only when you're looking at some of the larger like basement schemes, and when we're getting sort of in excess of 10 meters deep is where we tend to draw the line between category 2 and 3. Anything particularly unusually high risk, we've got unusual surcharges, or rail interfaces is another one, or if you're working in river channels or in coastal works. Everything we've seen there is, like, for us, is relatively standard design. So just to be classed as category 2.
Okay, thank you. So that's all we've got time for today with the questions. If you do have any other questions, please send them to us by email. Thanks again to everyone for joining us today. If there is anything else that we can assist with, or you would like to arrange a presentation for your team, please get in touch through our website, and we look forward to seeing you in the next webinar.